Hey everybody, in this lesson we're going to talk more about polygons. We spoke about polygons in class. This time we're going to talk about some formulas that you can use to find out how big angles in polygons are. So polygons have two different types of angles. They have angles that are formed inside of the actual polygon, and then they have angles that are formed outside of the polygon. So the interior ones are inside, and you can see there are 1, 2, 3, 4 interior angles in this polygon. And if you notice, it has 4 sides. It's a quadrilateral, so it has just as many interior angles as it does sides. And then we have exterior angles. So these angles are formed by extending the sides. So I can extend each of the sides straight out, and that's going to form my exterior angles. And you can see I have 1, 2, 3, 4 exterior angles. So 4 angles that can be formed outside of the polygon. And again, those are formed just if we were to extend the sides. So a polygon has 4 interior, 4 exterior angles if it has 4 sides. If it has 100 sides, it has 100 interior and 100 exterior. So we can find out, if we're given any polygon, we can find out how many degrees. If we add up all the interior angles, we can find out how much they should add up to. So here I have again my 4-sided polygon. Probably a bit easier if we had a protractor to measure these, but let's say we had a 1,000-sided polygon. We could use this formula right here to figure out how many degrees inside the polygon. So the important thing here is to see that n in this formula represents the number of sides. So you should probably write that down. N is the number of sides in the polygon. So if we take the number of sides and subtract 2 and multiply by 180, it'll tell us how much all of the interior angles add up to. So if I were to add up the measure of each of these inside angles, that's what we're talking about. So we can do an example here. I want to find the sum of the interior angles of a 30-sided polygon. So n is 30, the number of sides is 30. That also means that the number of interior angles is 30. I'll start by writing my formula. If I write my formula every time, eventually it's going to be just committed to my memory. And then I'll plug in what I know. Well, I only know one thing. It's that n is equal to 30, so I plug that in. Subtract 30 minus 2, do some multiplication, and I find out if I were to measure all 30 of those angles and add them together inside that 30-sided polygon, it would add up to 5,040 degrees. So go ahead and pause here. I want you to find the sum of the interior angles of this polygon. Notice that there are 5 sides here. So because there are 5 sides, that means my value for n is 5. I'll have 5 interior angles. Again, I start by writing the formula, and I've started to abbreviate interior and angle here to kind of make it easier on myself. Plug in that n is 5, and eventually simplify to find out that all the 5 interior angles, if I add them up, add up to 540 degrees. So there is really no formula for the exterior angle sum. No matter what polygon I have, no matter how many sides it has, it could have a million sides. If I were to extend all those sides, measure all of those exterior angles and add them up, they're always, always, always going to add up to be 360 degrees. So this is just a fact that we can use and that we should know. All the exterior angles in a polygon add up to 360. We have special kinds of polygons that we'll talk about, and they're called regular polygons. I guess the word regular doesn't really make them sound special, but they are special. And they're special because all of the sides in those polygons have the same length. All of the interior angles in those polygons have the same measure. And all of the exterior angles in those polygons have the same measure. So if we're told that a polygon is a regular polygon, then we know these three facts about that polygon. The sides are all the same size, the angles are all the same size inside and out. So we found the sum of the interior angles of any polygon, whether it's regular or not. Now we're going to find one interior angle if we know that the polygon is regular. So you can see here that we have the formula for for the sum of the interior angles, and since all of the angles are going to be the same size, we can just divide that by n, the number of sides, to get one interior angle. So let's do an example of that. Here I have a 8-sided polygon. There's my octagon. It looks like all the sides are the same size and all the angles are the same size. And I've told you that it's a regular polygon. So if I want to find one interior angle, I can use my formula, and I should write it down every time, and I'll always remember it. I plug in n in 2 spots. So I plug in 8 for both spots where n is. I can simplify the top, and then I can do the division and get that one interior angle of this 8-sided polygon is 135 degrees. That means each of these angles is 135 degrees. And you can see up here, this 1080, that's how much all the interior angles should add up to. Dividing by 8 gives us 1. So go ahead and give this example a shot. Pause the video and find the measure of one interior angle of a regular nonagon. So we need to know that a nonagon has 9 sides. So n is 9. And then we can write our formula, write it down every time, and we plug in 9 in both spots for n. Simplify the top. 1260 is going to be the number of degrees if we add up all the interior angles. Then when we divide by 9, it's going to tell us that one interior angle is 140 degrees. So each of those 9 angles inside this nonagon measure 140 degrees. So we spoke quickly about all the exterior angles in any polygon, even if it's not regular, adding up to 360. But we know if the polygon is a regular polygon that all the exterior angles should be equal to each other. They should be the same. So that means if we want to find the measure of one of them, all we need to do is take 360, the sum of all the exterior, and divide it by the number of sides, n. So we have our octagon back. And remember, it has 8 sides. And I'm telling you it's a regular polygon. So we're going to find one exterior angle just by using that relationship, that formula. Write the formula every time. Plug in 8 for n. Real quick simplification, and we find out that every exterior angle is 45 degrees. So that means if I draw one of these exterior angles right there, that's 45 degrees. So go ahead, do your thing, pause here, use the formula, make sure you write it down every time, and then I'll have you check your answer. So we got our nonagon back. Remember, it has 9 sides. Write our formula every time. Plug in 9 for n. When we do division, we find out that if we draw the exterior angles and measure them, each one of those exterior angles of this nonagon is going to be 40. So I want to make a really quick note here. If I go back one slide, my exterior angle for my octagon was 45 degrees. If you can remember or go check back in your notes, we also found the interior angle, and each interior angle was 135 degrees. Let's go back and check. There it was. So 135 and 45 add up to be 180. So another way we can solve these problems is if we know an interior angle, we can find an exterior angle of a regular polygon because they form a linear pair and they're supplementary. So you can see this interior angle and this exterior angle form a straight line. They're a linear pair and they add up to 180. So I want you to do these three. Use this polygon here. I'm telling you it's a regular polygon, and I want you to find each of these three measures.